Okay, hello everybody. So we're starting the first lecture, which is called Number and Names. Hurrah! Okay, so numbers. What are numbers? We have a lot of them around, but do we really know what is it? So what I will speak today will be more about questions and less about answers. So I suggest you to ask as many questions to everybody else, not me, maybe me later, but not today, and to seek for answers. Okay, so let's start. So numbers, what are those? Like we see around lots of numbers, like leaves on the trees, planets in the sky, stars, people, everything goes in numbers. I don't think that you can even find something that can be only in one. Usually there are too many. So numbers, we have, like, for example, one planet, another planet, one star, another star, and we have maybe Christmas tree, one Christmas tree, another Christmas tree, and we want to count them. Okay, somebody asks you, just count. But the question is, count what? You can count planets, you can count stars, like 3 stars, 2 planets, like 2 Christmas trees, maybe 3 Christmas trees. But if somebody asks you to count everything, what would you do?
Count.
Okay, count. So how can we count? One planet, another planet, the star,
One
something,
star.
the Christmas tree. So something definitely is not going well here, right? So let's take a look at what's going on. So we can easily count planets, we can easily count stars, we can easily count Christmas tree or something else. But we want to count everything here. What will we count? Okay, will we count 1, 2, 3, 4, 5, 6, 7, 8? 8 of what? What would it count here?
Everything.
Everything? What is everything? We don't have everything, like we touch everything or something. We can see at least planet, we can see stars, we can distinguish one from another, but we don't know how to count everything. So maybe we can count, like let's count something that is in this circle. But again, if we're counting stars and planets all together, the question is, what are we counting again? Something that is in this circle, right? But what is something? Very indefinite answer. So when we're counting, we should think of something that is similar to each other, like planets are somehow similar to each other, then we can count them. Stars, they are somehow similar to each other, so we can count them. Same thing, trees, maybe Christmas trees. But even if we imagine that we have not Christmas tree, but just some other tree, can we count? So probably we can say yes. Let's count trees, whatever they are, that tree or another tree. So we have so we should find some similarity or some identity between the regular tree and Christmas tree and the other Christmas tree. And if we look deeper, we would see that Christmas trees are all different. And the trees, if we see many trees, each tree is different from other. Or if you look at the leaves on the trees, each leaf is unique. The same thing as people. If you try to count how many people live in this world, we can probably count, but again, what are we counting? Each person is unique. So if you count them all together, then we say that something identical in all of them exists. But how people can be identical if they are unique? So it means that when we're counting, we say that things in the world can be identical and unique at the same time. Or you may say that we can count them exactly because they are unique, All of them are unique, and that's why we can count them. Each of them is unique, like everybody else. So what is this? This is called paradox. If something is identical, it cannot be unique. If something is unique, it cannot be identical. But somehow we see that all the things around us are somehow partly identical and partly unique. So we should think about it. This is a more question again than the answer. Now we going closer to counting. If we try to count, so we found something identical in the things, and then we can call the thing that we count, we can call it, usually when it's one, it is called a unit of the count, unit that we're counting. Okay, this one unit, of course, if we want to talk about it, we should name it somehow. It should have a name, like a Christmas tree or whatever. But usually in mathematics they found some other names. How it was in the history? In the history, ancient people they actually giving the whole names for each number that they found. Like for the first, the one, they can call it, like for example, A. If they have two, they can call them like B, for example. If they have three, they can call it C. And like this, right? Like 4 would be like D, whatever. So we're using letters of the alphabet here. So we have alphabet, and the alphabet comes from language. So somehow we're using language to count. And really, if you talk about like how people call names, originally, like for example in English, it is what goes with words of language. 1, 2, like 3, 4, 6, 7, up to maybe 11 and 12. So they all are unique words, unique names. Each of them corresponds to certain number of things. Further goes something else. They come teens, like teenagers and whatever. They come teens and then something else. They have something different from the beginning. But before that we have just 12 names. 12 names for 12 numbers, right? So these numbers are called numerals. Then they come other more smart people, maybe a little. They invented, there was Arabic people. They invented Arabic numeral system, which goes with the so-called numerals 1, 0, 1, 2, up to 9. Up to 9. So they suggested just 10 of these numerals. What are those numerals? What are them? They are the same. They are the same alphabet. We can easily be 0 can use, instead of 0 we can use A, instead of 1 we can use B, C, and up to 10th letter of alphabet. But Arabic people, they decided to use these things, and now we know them as numerals. So numbers from 0 to 9. But they didn't stop at that. They thought, what would we do if we have lots and lots of numbers? Like for example, in regular alphabet, like in English alphabet, we have only 26 letters. So we can give names only to 26 numbers and not more. But what about more? If you want, like, see stars in the sky, there are thousands of them, and we can use only 26 letters. And then people, they go in different ways. Arab people, they invented so-called Arabic numeral system. We'll talk on this. And like people in Orient people, like Chinese and everything, they invented something that they call hieroglyphs. They use something like alphabet maybe in the beginning, some things like maybe that or that, some symbols, and then they started adding something to this, like this or this, or this, that kind of additions, changing the pictures of letters, make them more and more complex. And these things, they are called hieroglyphs or pictograms. There are also some sort of a small pictures of something. They use it in language too, and they use it for the numbers too. And they have thousands of them. So again, it's not that really good system. You should remember all these thousands of things, and that's a real problem for Chinese, especially in the modern world. So what Arab people did, they not only suggested these numerals, they also suggested a way how to name other numbers more than 10. Here we have only 10, 0 to 9, right? More than 10. So what they suggest? They suggest very interesting thing. They circled this system. They say if we count from 0 to 1 to 2, blah, 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 to 9, and then we just go back and start from 0 again. That's okay, maybe this is, but how it helps us? And they say we use positions. So they say like this: we go right 0 when you have 0, 1 you have 1, then up to 9. This go this, and here we go circle to 0. So after 9 we put 0, but like to differentiate this 0 from this 0, right? It's like circle, right? We add 1 here in the first position before 0, and this we call 10, as we know. So they suggest the way how to use alphabet of 10 letters to create names that didn't exist before. If we go further, again, we count from 0 to 9. So we have again 1, 2, blah, 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 9, 0 again. And here we add here 1 again. So we put 2 here. And as you know, it goes further here, right? So we go from decimal things, we go to hundreds, and then thousands, and more and more and more. So this is called the Arabic numeral system, or numeric system. So they invented a way how to use it. What kind of way, what this way is named? These rules, so we have some rule how to write, to give a name to a certain number. This rule is known as grammar. So it's a grammar rule, and so this, with the Arabic invention, the naming become a real language. It starts the real language from that point. So the naming system is the beginning of a language. With the alphabet, so we can use very short alphabet, and we can go further and further. How long can alphabet be? Different nations has different alphabets. Like English people have 26, like Russian have 32. So Chinese have thousands because their alphabet is just pictographic, so hieroglyphs, thousands of hieroglyphs. But there is one particular system which is widely used right now, and it's called binary. And binary system has only 2 letters, like for example A and B. 2 letters, that's all, the whole alphabet. But it happens so that instead of using A and B, they started using this Arabic numbers 0 and 1. So what they do, like here, how they count them? They do the same thing. They have 0 and 1, and they use it in circles. So they start from 0, not from 1 like usually, but start from 0, then they gives 1, then 1 returns back to 0. And they use the position system the same like in Arabic. So we have 0, then we have 1, and we're counting this way, 0, 1. Then after 1 we should come again to 0, right? Circle. So we have 0, but we should put here 1. Because here was zeros, of course. We may add zeros here. They're still zeros. This is 0, this is 1. This is 1, 0. In decimal system we call it 10, right? But it's not 10. It's actually number, if you look at this, this is 0, this is 1, and the next after 1, this is number 2 in decimal system. So in binary 10, in decimal it's 2. Now we continue counting here, right? So after 0 goes again 10, again 1, then, and here of course it's 1, because it's 1 that goes further and further. So we have 1 here. Now the next will be 0, but we go circling and we're adding to this one, we're adding another one. 1 plus 1, adding 1. After 1 goes what? After 1 goes again 0 here. So we should write here 0. And we add another one here. So each time we make a full circle, we're adding 1 here. When adding 1 to 1, we get 0 again here, because after 1 goes always 0. So here is circle finished here too. First circle finished here, second circle finished here, and then we put 1 here. This is called binary system. Very useful in computers and everywhere. But okay, this is just a little about alphabet. Now, what's happened later? One of the questions that actually very often comes: what is this unit can be? What is this unit? Okay, we have like one Christmas tree or one planet or whatever, but what is the unit, which we call 1, right? In Arabic system, this 1, or whatever we name it. So what is this unit? Okay, let's talk about things that have the name of abstraction. What is abstraction? Abstraction is a process of that kind. We have a Christmas tree. The real Christmas tree has this stem, has branches, has roots on the ground, right? And actually a tree not alone. Usually it stands with other trees in the forest, right? And many trees in the forest. So we come to the forest and we want to somehow transform one of the trees that we selected to the unit. So what would we do? Usually what is done, we cut off the tree first. So we separate it from the forest. What we do next? We cut off the branches and we have just a stem. Then we make the stem to make it smooth and maybe shorter, to simply operate with it. Something very, very short. You see, it's almost looks like a 1, this part of stem, right? Instead of this, we can use something that's very similar to this, like a finger on your palm, a finger on your hand, or something else, whatever we want. So this process is called abstraction. We are abstracting from everything, from the forest, from the branches, from the roots, from everything, even the part of stem, lots of things. And what we have this stick, right, which is very simple, and because it is simple, we can manipulate it easily. We cannot, like for example, it's very difficult to build like for example house out of the Christmas trees, especially if they are still in the forest. They hold with all their roots, they hold in the ground and everything. It's very difficult to do something with this tree. But when you already processed it, you cut off everything, you can take all these sticks and you can build, for example, some house out of the sticks. The same thing you can do a fence again, or these sticks, and many other things. You can even pave the road, right, from your house to somewhere else with the sticks. So lots of things can be done with the sticks, and that's the whole point of doing them. The same thing is done in, believe it or not, the same thing is done in mathematics. They just simplify the real things to the level which we can easily manipulate, and we use it as a unit which we name as 1. The same thing we use other names and the Arabic system and everything. Like Arabic system can be only invented when we already simplified the whole thing, the unit to the level that have just one stick, another stick, or empty space which we name 0. Now, just a little more on this. When we start counting, and not only counting, but using these units like a real tool, like these sticks, right? Mathematicians, they do that. They display it like this line, which is called number axis, and they put on this number axis, they put all these numbers. So this is 0, then 1, then 2, then 3, then maybe 10, and further going on. What we have here? We have here a sequence of numbers, and usually it is said that like 2 is more than 1, 1 is more than 0, 3 is more than 2, and like there, right? So it goes far and far away. But if you look at this thing and think about it, what this point presents here, you will see that this point is the same unit as this unit. They're all the same, they're all identical, because we're counting identical things, like identical trees, identical leaves, identical planets. So they're all the same. The only thing is different is the position. So it's a positioning system, and this system is called order or ordering. So we put the next thing like on the right of the previous thing. So they're coming in order. And that's again this very useful tool, this axis and the ordering, until we understand that there are no straight lines in the world around us. There was examples like given what kind of straight line we have in our around us in this world. What we have, like for example, the beam of light, right? Like beam of light that comes from the laser, right? For example, here we have laser, and it gives a very strong and very straight beam of light. It looks like a real line, which we can use maybe for ordering, like in the space, right? But if you go into it, we see that this beam actually it consists of many particles. They're called photons, the particles of light, which are not going in the straight line at all. They tend to gather around the straight lane, but some of them goes very far from the lane, and some of them very far. So there are lots of forces around. So this is not a line at all, not a straight line at all. If we try it like something that we know better, like in the class, like a ruler, right? We have a ruler, and we think that this is definitely should be a straight line in the ruler, and we use it like to put straight lines on the whiteboard. But if we take a magnifying glass and look at the ruler, we'll see not a straight line, but we'll see that kind of line. Because in reality, it's very difficult to make this surface really smooth. So the more magnifying glass, the more powerful is the magnifying glass, the more things we see here. So there's no straight line either. And if you look at any line in reality around us, you will see that there are no straight lines. It means one interesting thing, that when you count the real numbers, not the imaginary that we put here, like some numbers that we invented ourselves as a tools, like when we're cutting off the branches and everything, like from the Christmas tree. The real numbers goes not on the axis, but actually they go like this. And if you use the magnifying glass, they can go very far. So they goes like, and sometimes maybe back. So this is one another complicated thing, or the complicate the real things in this world. So, and that's, I think, that's enough for today. That's a small introduction where we go further. Just think about it, ask questions, and then we return to much more mathematics next after this. Thank you.